Hi everyone, welcome to our YouTube channel. So in this video we are going to discuss a problem of rating 1300. As you can see, the rating of this problem is 1300 and the problem tags are binary search, data structure, DP, gradient, sorting. So what the problem is, let's discuss. In this problem you are given an array of size n and you have to count the number of pairs of indices such that a of I should be less than I and I should be less than a of j and a of j should be less than a of j, which means we have to find a pair such that the element of this pair should be less than the index, and we have to find two such pairs so that this value should be satisfied. So let's see the test cases of this problem. So let's say this is the first test case. As you can see, the first index value is 1, so it is not less than the index, but you can see at the second index the value is 1. So yeah, we can say at second index value is less than the index. So this can be counted as the pair, and this is also can be counted as the pair because this value 2 is at third index and it is less than 3. So discuss this test case in whiteboard. So this is our test case. As you can see, this is the first index, this is the second index, this is the third index, this is the fourth index, this is fifth, this is sixth, oh sorry, this is sixth, this is seven, and this is eight. So as you can see, a of I at this index is less than I, and at this index also a of I is less than I because it is 2 and it is 3, and this value also satisfy the condition. This is this one and this one. As you can see, these all 6 indexes are satisfying the conditions. So what we have to do in this problem, we have to count such that a of I should be less than I and I should be less than a of j and a of j should be less than a of j. As you can see, here is the catching point. The catching point is j should be greater than everyone in every cases. Those pairs which we have to count, j should be greater than all the values a of I and a of j. So what this hint is given in this statement is we have to count from the end. As so let's start count from the end. As you can see, I have written the index positions where the conditions are satisfied and the values below them. So as I have told you, the value of j should be greater than a of I and a of j. So it means we have to counting from the last position of the array. So here those indexes and values are given where the condition satisfy, and I have written them separately from the array. This is the array. So at the last position, at the jth position, the value is 4. So as you can see, a of I should be less than I. Let me write it again. So let's start with the endpoint, and here the value of j is 8 and a of j is 4. So we have to find the value of I such that 4 should be greater than I. So these are the values of I. Here value of I is 2 and here is the value of I is 3 and here value of I is 4. So you can see 4 is equal to 4. So we can take these two elements to make pair with it only. Only these two elements will satisfy the condition to make pair with this. So you can say, yeah, it could make pairs with two different elements, 1 and 2. So let's check this one. we have checked at index 8 and we have to check at index 7. So here the value of j is 7 and value of a of j is 1. So as you can see, the value of 1 is not present here. So we can take, yeah, this could not be considered as a pair with anyone. So here we will take 0. And after that, let's take the value of j 6, and here value of a of j is 2. And you can see this is also cannot be take with anyone because 2 equal to 2, and we have to take greater than not equal to. So it will also contribute 0. So let's move on the next 4. So here value of j is 4 and a of j is 3. So let's take those elements which are less than 3. So you can see here 2 is less than 3. So it will contribute 1. So let's take, it will contribute 1. So here a of j is 3 at next level, and a of j is 3 and a of j is 2. And it will contribute 0 because less than 2 there is none index. So it will also, last element obviously, first element will also contribute 0. It can't pair with anyone behind that. So let's count total contribution, how much total contribution has been done in this condition. So here one contribution done and here two contribution done. So overall contributions are done are 3. So that's all the problem what we have to do in this problem. So as you can see, I have iterate the array which I have take those elements at different array and push them, and I have started from last index to first index, and I have binary search this value. uh, I have taken the lower bound of 4 where 4 present. As you can see, 4 is present there. So that lower bound will point here, and we can say at, if we take 0 indexing, 0, 1, 2, as you can see, it, the value of elements before 4 are 2. So it will contribute to, yeah, there are 2 elements before 4 which will contribute to our answer. So that's all the logic of this problem. So let's go to the code section of the problem. So as you can see, I have taken input in, and it doesn't, don't be afraid of this. This is in, and uh, here I have taken the input of n and array a. As you can see, I have taken the value of array with one indexing. So I have started from 1 to n, and you can see I have taken vector. This is vector. Sorry, let me write it again. So this is vector v, and it is also vector. So in this vector, I will push the values. As you can see, in this vector v, I have pushed the values of the index. Vector v values will be pushed in vector v will be these, and which means the actual values. And in v1, I have pushed the index to binary search them. Okay. So as you can see, in v I have pushed values, and in v1 I have to push the indexes of these elements, and I have reversed the vector v because we have to iterate from last to first. As you can see, I have taken the lower bound of this value v of I, and minus v1. You can search it at geeks for geeks. What is the meaning of lower bound? You will get the correct what does it mean. So as you can see, I have taken the sum of all contribution, how much it is contributing to our value, and finally I have printed my output at this. So that's all from my side. If you have any comment, if you have any doubt, then feel free to comment in our comment section. Thank you guys. Bye bye.